area between curves. So suppose you want to calculate the area below the function y equals to f of x and positive part of x-axis as x bounded between a to b. Well, it's not that difficult. It is basically the definite integral a to b of f of x d of x. Suppose you have another function like g of x, and your goal is to calculate the area below g of x and positive part of x-axis between a to b. This is the definite integral a to b of g of x dx. Now the idea is, how do I calculate the area between f, which is the function on top, and g, which is the function down here? So intuitively, you have a larger area minus the smaller area. The larger area minus the smaller area gives you the area in the middle. Now I ask you to find the area of the region bounded by parabola y equals to 2 minus x squared and the decreasing line y equals to negative x. What's the approach? So first of all, let us visualize this. What's going on here? If I try to graph 2 minus x squared, this is basically a parabola which it opens downward. The leading coefficient is negative, so this is your 2 minus x squared, and the decreasing line, negative x. We want to know what is the area between these two graphs, right? On top or ceiling, or the larger y value is 2 minus x squared, and the smaller y value is minus x. We have a nice formula for that. But what is the starting point? What's the terminal point? We know that we need to use the definite integral, but what is these two starting and ending points? I know it's given in the question here. When you look at this, visualize this, but what if these numbers weren't here? How do you find them? To find these intersecting points, set these two functions equal to each other. Set f of x equals to g of x. So 2 minus x squared, which is the function up there, set it equal to negative x, which is your second function down here. Okay, bring everything to one side to form a quadratic equation. You get x squared minus x minus 2 equal to 0. We can use factoring method or using quadratic formula to solve this. Factoring is easier, right? X squared minus x minus 2 can be written as the multiplication of two linear terms, x plus 1 times x minus 2. And you're going to set it equal to 0 because you have 0 on the right-hand side. If you set x plus 1 equal to 0, x is negative 1. And when you set x minus 2 equal to 0, you get x equals to 2. So you found the intersecting point at negative 1 and 2. So now you can move on and calculate the definite integral. The area between these two functions is the definite integral a to b of the larger y value, which is definite integral negative 1 to 2 of 2 minus x squared Again, this is your ceiling or larger y value, minus the smaller y value, your g of x, which as you can see is negative x. Then you take the integral with respect to x. Sometimes it's easier to take the integral with respect to x. Some other times it's easier to take the integral with respect to y. For this case, everything is written nicely. Calculation of integral is also very easy, so we're not going to change anything. This can be written as the definite integral of 2 plus x minus x squared dx. And then remember the shortcut when you have the power function, the integral of u to the n du is u to power n plus 1 divided by n plus 1 plus constant of integration. And for the definite integral, we just plug in 2, then we plug in negative 1 and do the subtraction. So one by one, we're going to calculate this integral. This is equal to 2x, the integral of 2 dx is 2x, plus the integral of x is x squared divided by 2, and the integral of x squared is x cubed divided by 3, and x ranges between -1 to 2. Okay, so if you plug in 2, you have 4 plus 4 squared, 2 squared, which is 4 divided by 2, minus 2 to the third, which is 8, divided by 3, and then minus, you plug in -1, which is -2, plus 1 divided by 2, plus 1/3, because you have -1 to power 3 becomes -1. You have two negative signs, so it becomes positive. And when you do the calculation, it is 9 divided by 2. So this is the area bounded between these two functions. This is the simplest calculation for the area bounded between two functions.